In the previous video, you should have learned about Chebyshev's rule and how it is different from the empirical rule and when to apply which. So now we're going to go through a couple of different examples to apply those rules. So in our first scenario, we're looking at exam 1 scores. It says they are skewed to the left. So first, let's just think about what skewed to the left looks like. So that means majority of the data is actually on the right, and we have a little bit of data there on the left, so it's skewed to the left. We have a mean of 75 points and a standard deviation of 11 points. We're going to describe the results that I would obtain if I take a sample of students' exam 1 scores. And it also just says that note that the score should be between 0 and 103 points. Well, first, let's discuss which rule is appropriate. Should we be using the normal curve rule, the empirical rule, or Chebyshev's rule? Now, because it told us that the data set is skewed left, we know it's not symmetric, so the normal curve rule will not apply. So for that reason, we are going to have to use Chebyshev's rule. Then what I usually like to do is draw myself a number line. We're going to be doing very similar math to what we did in the normals notes. I'm just not putting that normal curve on top of it. But I'm going to start by looking at where the mean is, and the mean was 75. And then I'm going to go up to 3 standard deviations below that, and 3 standard deviations above that, where each of my standard deviation distances is just that 11 that was given to me. So doing that math, here are the values that we should obtain, just subtracting 11 each time I go to the left, and adding 11 each time I go to the right. So we already discussed that Chebyshev's rule is going to be the one that we want to use. What we also learned is that when I go out 1 standard deviation with Chebyshev's rule, I'm not really getting any useful information. So I'm not going to bother even reporting this one for Chebyshev's rule. I'm just going to do the 2 and 3 standard deviations out. So let's first find those on our picture. So my 2 standard deviations out is going to be from this 53 to 97. And then my 3 standard deviations out is going to be this 42 to 108. So those, let's interpret. So first, I can then say that at least 75%, since we are 2 standard deviations out, of students would score between and here we got the 53 to 97. Points on the exam. Now, let's do the 3 standard deviations out. So the 3 standard deviations out for Chebyshev's will be at least 90% of our students would score between (42) and, well, based upon the math I did up here, I would like to say 108. However, with what they told me here in the problem, the largest possible score is 103. So I kind of just want to stop it there. That's the largest possible. Now, I don't know if anyone actually will score it, but it's the largest possible value. So I'm going to stop it then at 103 points. sense. That way what I'm interpreting at least makes sense in the end. The next question asks us what would change in this problem if instead I would have known that the exam scores were symmetric and bell-shaped. Well, if I would have known that, then the normal curve rule would apply. So what would be different? Well, first, the math up here would not be different. The mean is still 75 and the standard deviation is still 11. So I would still get the same numbers that I see there. What I would get to say instead, though, is that my 68% of students would score between the 64 and 86 points. Because one standard deviation out is useful for the normal curve rule. I would get that 95% of students would score between that 2 standard deviations out, so the 53 and the 97. And finally, for my 3rd standard deviation out, we would get that 99.7% of students. And I would still use my 42 and the 103 that we discussed above for the same reason. So the math is no different. It's just what we can say about those numbers is different. Up here, at least 75% are between 53 and 97, versus down here, it would be exactly 95% if it was symmetric and bell-shaped. All right, so let's try another example. If you want to see how you're doing on the material, you could always pause the video here, try it on your own, and then come back and see. So we're going to be going back to example 1. So let me page back here together for us. So this is our one looking at the PGA golfers. So we have our mean. We have our standard deviation. We also have our graph to look at, which we describe this graph as being unimodal and skewed to the right. So using that information, what rule do we think we should use? Well, hopefully we would agree that we should be using Chebyshev's rule here, because this graph is skewed to the right. It is unimodal, but it's not symmetric. It's skewed to the right. So now using that rule, we're going to create and interpret an interval that is 2 standard deviations from the mean. So unlike our first example where we did sort of all of the math, this one's just asking us to go out 2 standard deviations and just interpret that one. So starting the same way, we're going to start with that mean that from our StatCrunch output was that $1.26 million value. This time, since it says to go out 2 standard deviations, I'm just going to go out those 2 values. And then we're going to use our standard deviation, which was this 1.24 million value, as the size of my increment. So subtracting to the left, first we'll get 14,129. If we subtract again, what's going to happen? Well, I'm actually going to get a negative number. And we were talking about salaries, like the earnings of the players. The earnings could not go negative. So I'm just going to kind of stop it at 0 because it's going to make no sense to include a negative number in my interpretation. But now if I add my standard deviation up here to the right, we get a little over 2.5 million for the first standard deviation out, and a little bit more than 3.7 million for the second standard deviation up. So the two numbers I'm actually going to use are the 0, because I can't have a negative earnings, and this 3.7 million value. We already discussed that we're going to use Chebyshev's rule. We went out 2 standard deviations, so that 2 standard deviations will give us at least 75%. So then now I can say that at least 75% of PGA players had earnings between $0 and that 3 million value in 2013. Again, not everybody, at least 75%. So if we actually go back and look at our graph, that roughly gets us from here, that $0 amount, up to about roughly in here. So does that look like about at least 75%? Yeah, it's probably more, but it's definitely at least 75%. So there is a couple of examples of Chebyshev's rule, as well as remembering the normal curve rule.